Simplify rational expressions. A rational expression is a quotient of two polynomials. Notice the word quotient. Quotient means division. So rational expression is the division of two polynomials. Here are a few examples. 1/2, a plus 3 divided by a minus 7, or x squared minus 25 all over x squared minus 7x plus 10. Notice these are all written in terms of division, or in essence, it looks like a fraction. Because a rational expression is a fraction, we follow the same rules as fractions. To simplify, we reduce the common factors that appear in both the numerator and the denominator. To multiply, we do top times top, bottom times bottom. To divide, we multiply by the reciprocal of the second fraction. And whenever we are adding and subtracting, we must have a common denominator. To simplify rational expressions, let's go back to what we do know. The basic versions where there were just numbers existing. So let's look at the problem that says simplify the fraction 24 over 32. Well, we go back to the basics. We go back to the prime factors. 24 is made up of 2 times 2 times 2 times 3. So that way we see each of the factors. 32, if you do the prime factor tree, is made up of 2 times 2 times 2 times 2 times 2. So again, everything is in factored form. Now to reduce it, we have to find factors that appear in both the numerator and in the denominator. So because we had a 2 in the top and the bottom, they reduce to a value of 1. Do you see any other common factors? We have another pair of 2's that reduce. Anything else? We have another pair of 2's. Is there any more? And it turns out that is it. So our final answer would be 3 over 4. Now that's the basic version where we have just numbers. What about the algebra version? So let's look at an example. Say it says to simplify 3b plus 12 all over 7b plus 28. Well, first we have to factor this to see the individual factors. Now remember, factor means to always first look for a GCF, then if necessary do the AC method, and we break everything down. So looking in the numerator, we have 3b plus 12. First we ask, do they have anything in common? And they do. And in the bottom, do they have anything in common? They do. And so, in factored form, you should see 3 times b plus 4 for the numerator. And in the denominator, you should see 7 times b plus 4. Now that we see the factors, we have to reduce the common factors. So in the top, you have two factors. 3 is a factor, and b plus 4 is a separate factor. In the denominator, you have a 7 as a factor and b plus 4 as a factor. And if you notice, our common factor is b plus 4 appears in both the top and the bottom. So our reduced answer would be 3/7. Example 1, simplify. And so for A, we have 12y plus 24 all over 48. Now remember, we need to factor these down so we can see the individual factors. So off on the side of our paper, we're going to do our side work. Looking at the numerator first, I have 12y plus 24. Do they have anything in common? And they do. They have a 12. And if I factor out a 12, I now have 12 times y plus 2. Now 12 is its own factor and y plus 2 is its own factor. Can 12 factor down anymore? Well, 12 is not prime, so 12 is made up of 2 times 6, and we still have the y plus 2. Can any of those factors reduce, again, like factor down? And the 6 can. So we can now rewrite that as 2 times 2 times 3 times y plus 2. Now everything is clearly written in terms of its prime factors. Now that was the numerator. Now let's look at our denominator of 48. 48 is made up of 6 times 8, but 6 is made up of 3 times 2, and 8 is made up of 4 times 2. But we're not quite completely factored yet. The completely factored form of 48 would be 3 times 2 and 2 times 2 times 2. Now that both the numerator and denominator have been factored, let's put it back together as the fraction. Once you have it back written into a fraction, now we want to, if possible, reduce. So look anywhere in the numerator and the denominator. You'll notice we have a 2 in the top and in the bottom. We have another set of 2's that appear in the top and the bottom. And we have 3's that appear in the top and the bottom. But from here, there's nothing else that's in common, so our final answer would be y plus 2 all over 4. Example B, we have x squared minus 1 all over 4x plus 4. So again, we're going to do our side work on the side of our paper, and we're starting with our numerator of x squared minus 1. We check and see, do they have anything in common? And they don't. So we move on to the AC method, and what you may notice is the middle term's missing. So I rewrite it as x squared plus 0x minus 1. Now I would do my first times my last and expand your middle term, which would give me x squared plus x minus 1. Now that we have 4 terms, you do factor by grouping. So the first 2 terms you factor, and the last 2 terms you factor. And you should get x times x plus 1 minus 1 times x plus 1. And so to factor it completely, you would get x minus 1 times x plus 1. Now that was the numerator. Now we're going to factor the denominator, 4x plus 4. So again, we always ask ourselves, do they have anything in common? And they do. They both have a 4. So we rewrite it as 4 times x plus 1. But notice 4 can factor again. 4 is made up of 2 times 2 times that x plus 1. Now that everything is completely factored, we rewrite it together as that fraction. So we have x minus 1 times x plus 1 all over 2 times x plus 1. Now that everything's factored, let's reduce if possible. Is there anything that appears in the top and in the bottom? And you will see x plus 1 appears in both places, so it reduces to a value of 1. Are there any other common factors? No. So your final answer would be x minus 1 all over 4. Now I do want to mention the parentheses around the x minus 1 help you to visually know that those two belong together. Technically, the parentheses are not required, but I strongly suggest you keep them. Example C, 2x squared minus 11x plus 12 all over 2x squared minus x minus 3. So again, we are going to have work on the side of your paper. Starting in the numerator, 2x squared minus 11x plus 12. Because we're factoring, we always start with, do they have anything in common? And in this case, they do not. So now we would do the AC method, your first times your last, and then expand your middle term. which you should find to be 2x squared minus 3x minus 8x plus 12. Now that you have 4 terms, split it and do factor by grouping. And you should find x times 2x minus 3 minus 4 times 2x minus 3. And the GCF has just revealed itself, and so completely factored, you should get 2x minus 3 times x minus 4. Again, that is just your numerator. Now let's look at our denominator. 2x squared minus x minus 3. Because we're factoring, we first check, do they have anything in common? And they don't. So we do our first times our last. We find our two numbers and expand the middle term. And you should get 2x squared minus 3x plus 2x minus 3. Factor the first two and the last two. And I hope you find x times 2x minus 3 plus 1 times 2x minus 3. And so in factored form, you should get x plus 1 times 2x minus 3. Now that they've been factored individually, we bring them back together as the original fraction so that we know the location of each of these factors. Looking at the fraction, is there anything that appears in the top and in the bottom? Any common factors? And you should notice 2x minus 3 appears in both places, so they reduce to a value of 1. There's nothing else in common, so your final answer should be x minus 4 all over x plus 1. That is your final answer. You cannot reduce the x's, so if you feel that instinct, make sure you continue to keep the parentheses around your x minus 4 and your x plus 1, because that means that those terms belong together. You cannot piece them apart. Example D, x squared minus 2x minus 8 all over x squared minus x minus 6. This is your try it problem. Okay, let's see how you did. On the side, you should have the following for your numerator. I have all my factoring work shown on the side and all of your denominator work. When you bring it together, it should look like x minus 4 times x plus 2 all over x minus 3 times x plus 2. Your common factor should have been the x plus 2's, which reduced to a value of 1, leaving you x minus 4 all over x minus 3. Example E, m minus 7 all over 7 minus m. Now, this one may look a little different. Notice in the top we have an m and a 7, and in the bottom we also have an m and a 7, but one of them may look a little odd. Which one looks a little odd, the numerator or the denominator? And you're probably thinking the denominator. 7 minus m is not the order we normally write this. We're conditioned to see the variable first. So what we are going to do is reorder this. We're going to take the m, the variable, and move it to the front. Now if I move it to the front, it has to keep the appropriate sign. Is m positive or negative? Because it's negative, when we rewrite it, it becomes negative m plus 7. Now that we have rewritten it, we notice our leading term, that m, is negative. Do we like our leading terms to be negative? No. So what we're going to do is we are going to factor a negative or a negative 1 out of those two factors. And whenever you factor out, it means you are dividing both terms by negative 1, which would give you negative 1 times m minus 7. Now that we have factored the denominator, let's rewrite it and see if we notice anything. In the numerator, we still have m minus 7, but I put parentheses around it to show that they belong together. And in the bottom, I now have the factored form of -1 times m minus 7. Has anything been revealed to you? Is there anything common in both the numerator and the denominator? And hopefully you see m minus 7 appears in both places, so they reduce to a value of 1, which means your numerator is a 1 and your denominator you're left with is a -1. Now, although this is correct, this is a fraction. Can we reduce? Can we divide 1 divided by a -1? And of course we can. The result would be -1, and that would be your final answer.